Okay, welcome back. This is a video about another related rates question. In this one, we've got a conical tank with water running out of it at a constant rate of 2 cubic feet per minute. The radius at the top of the tank is 5 feet, and the height of the tank is 10. And then it's asking how fast is the water level sinking when the water is 4 feet deep. So the first thing I want to do is draw a picture of the conical tank with water flowing out of it. Okay, so give me a second to do that. Okay, so there's my tank. And what I want to do is label it. And the first thing that I want to talk about is that water runs out of the conical tank at a constant rate of 2 cubic feet per minute. So when I write that, water is flowing out, okay, this is a rate, okay? And so water is flowing out, and since that's in cubic feet per minute, that's the rate at which the volume changes with respect to time, okay? And that's negative 2 feet cubed per minute, okay? So that's a rate, and that's dV dt. Okay, and I just knew that that was dV dt because of how the dimension said, feet cubed per minute. So the change in volume over time, okay? Now it also gives us some dimensions. It says that the radius is 5 feet, so I'm going to come up here and label that that's 5 feet, and that the height of the tank is 10 feet. So I'm going to come here and I'm going to label this dimension from here to here. And let me erase part of that, as 10 feet. Okay, so this is 10 feet. All right. And so what it wants to know, it wants me to find how fast is the water level sinking when the water is 4 feet deep. Okay. So it wants me to calculate. So we want to do this. Zoom in and write. We want to find dH dt, okay, when h is equal to, what is it, 4 feet deep? When h is equal to 4, okay? So let's kind of go over here. Let me kind of label this. The 10 feet here is my height, okay, and 5 feet, that's my radius, okay? And what I know about the equation, because we're given the rate at which the volume changes, the equation that I want to write is the equation for volume of a cone, okay? And the volume is equal to pi over 3 times the radius squared times the height, okay? So one of the things that I need to do here is I need to take its derivative, okay? But before I do that, I need to realize that I'm trying to find dH dt when h is equal to 4, okay? I'm not given any information about the radius of the cone here that's created by the water when the height is 4 feet, okay? But here's what I do need to do, okay? I need to remember that if I were to take a cross section of the cone, and I'm going to do that here, I'm going to end up getting a right triangle here, okay? And I know that this is 5 feet, and I know that this is 10 feet, okay? And and the other thing that I know is that I'm trying to figure all this stuff out when the water level is 4 feet deep, okay? And so, but the thing of it is that I remember from geometry that given a situation like this, I know that this triangle right here is proportional to this triangle here. And I know that because of angle side angle, okay? And by proportional, I mean that we can write a proportion, okay? They're similar that we can write a proportion. So what I want to do is I'm going to label this as my height here and that my radius is here, okay? So the proportion that I can write is r over h is equal to 5 over 10, okay? And I could even simplify that, and I could say that r over h is equal to 1/2. Okay, and if I multiplied this both sides by h, then I end up getting this equation over here that r is equal to h divided by 2. Okay, and so what this is going to do, this is going to help me answer this question, because if I know that I have this proportional ratio, what I can do is I can take this equation here, r equals h over 2, and I can substitute this in for r over here. Okay, so let me demonstrate that I'm substituting that in. Okay, and so as a result, let me come in here, and I'm going to rewrite this now as volume equals pi over 3 times the radius, which is h over 2, quantity squared times h. Okay, and so now what I have is, let me kind of simplify this a little bit. This is going to give me volume equals pi over 3 times h squared over 4. Okay, h squared is h squared, 2 squared is 4, times h. Okay, so as a result, I'm going to get this for my volume. I'm going to get volume is equal to pi over 12. Okay, 3 times 4 gives me 12 times h cubed. Okay, and now I have a formula for volume that is strictly in terms of my height. Okay, and what I've done is I've gotten rid of the r. And the reason is because if I took the derivative of this function here, not only would I have to do the product rule to find the derivative, but I would get a dr dt when I took the derivative of r with respect to time. So as a result, but the thing of it is, guys, we're not given that information. We're only given what dv dt is, and we're trying to find dh dt when h is 4. Okay, so I had to get this volume equation strictly in terms of h. Okay, so now what I want to do is I'm going to take the derivative of this function with respect to t. All right, so I've got volume equals pi over 12 times h cubed, and I'm going to take the derivative of this with respect to t. So ddt of my volume, and that's equal to ddt of pi over 12 times h cubed. Okay, and so let's go ahead and take this derivative using implicit differentiation, and I'm going to get dv dt is equal to, I'm going to drop the 3 down, so I get 3 times pi over 12 times h squared times dh dt. Okay, and so remember, I'm trying to solve for dh dt here. All right, now let me simplify this just a little bit, and we're going to get dv dt is equal to pi over 4 times h squared times dh dt. Okay, now one of the things that I can do, guys, once I've taken the derivative, I can plug in my values. Normally I wait till the very, very end, but this kind of gets a little tricky here. And so what I'm going to do is I'm going to plug in what I already currently have. Okay, so I know that dv dt, that's -2. Okay, I'm going to plug that in. All right, I also know that h is 4, so I'm going to do pi over 4 times 4 squared, and then times dh dt. Okay, and so as a result, I'm going to simplify this, and I'm going to get -2 is equal to, what is that, 16 over 4, so that really just gives me 4 pi times dh dt. Okay, and so now I'm just going to divide everything by 4 pi. Okay, so as a result, what we can figure out here is that dh dt, okay, is equal to -2 over 4 pi. All right, which really simplifies down to -2 over 4, so I get, it simplifies down to -1 over 2 pi. Okay, and we got to remember what the value is here, what we're dealing with, feet per minute. So the height lowers, okay, the height goes down at a rate of -1 over 2 pi feet per minute. Okay, and you could find a decimal for this, but we could leave it as a fraction. Okay, remember, fractions are our friends. So this is a problem that you guys will see quite a bit. I would venture to say that it'll be, something that you'll really, 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 really need to know. Okay, so I would just pay attention to that. The main thing is, guys, is putting our volume equation in terms of one variable. Okay, and we do that by looking at the cross section of our cone here with the water level. Okay, and then setting up a proportion and then solving for that variable. Okay, so I hope you enjoyed this video. Please, hopefully it helps make sense with the rest of your homework, and we will talk about this later. Thanks. Bye.